Assalamualaikum warahmatullahi wabarakatuh. I am Najahanani binti Muhammad Nasir. So today I would like to presenting about transportation problem. Transportation problem is a linear programming problem that deals with the distribution of goods from the supplier to the consumer. There are three methods that can use in initial feasible solution, which are northwest corner method, minimum cell method, and lastly Volcker approximation method. So for the method to solve the transportation problem, we can use stepping stone method and modified distribution method. For stepping stone method, it have a negative required to do the stepping stone method.
Assalamualaikum, my name is Najiha binti Roslizan. I will present the question 1, which is the transportation problem question. The question asks to find the minimum transportation cost using the northwest corner method for the initial feasible solution and to find the optimal solution for this problem. The northwest corner method, we start from the top left of the table, which is on the first column of the warehouse 1 and the first row of factory 1. The demand shown for the warehouse 1 is 12 units and it can be completed by getting supply from the factory 1 because the factory 1 has a supply amount of 40 units. So warehouse 1 will not get any supply from other factories. Next, we will look at the demand from the warehouse 2 because the first cell of warehouse 2 is on the top left, excluded the cell that has been filled in. The demand needed for warehouse 2 is 50 units and it can be completed and supplied by factory 1 because factory 1 has a balance of 28 units after subtracting with 12 units. Next, we will look at the warehouse 3. Demand needed for the warehouse 3 is 20 units, but the balance that the factory 1 has only 13 units. So warehouse 3 has to get the supply of 7 units from the next factory, which is factory 2. The warehouse 4 and warehouse 5 will not get any supply from factory 1 because they are already out of supply and need to get the supply from the other factory. The demand of warehouse 4 is 50 units, but factory 2 only has the balance of 3 units. So warehouse 4 need to get the balance of the 12 units supplied by the factory 3 in order to complete the demand needed by the warehouse 4. While for the warehouse 5, they will get the supply from the factory 3 of 8 units only due to the balance after subtracting the demand needed by the warehouse 4. And the balance of the demand, which is 10 units of warehouse 5, will be supplied by the factory 4 to be completed. After all the demand and supply has been completed, we will calculate the total of transportation cost needed under the northwest corner method. So after calculating, the total cost of the transportation cost is $922. But this cost is not the optimal and minimum cost, and the optimal solution will be needed to know whether the cost calculated using the northwest corner method is already minimum or it can be reduced more. So the next step is to find whether the cost can be minimized using an optimal solution, which is the modified distribution method and also the stepping stone method. The table used in the modified distribution method is the same as in the northwest corner method, but has a slightly different that has been added, which is the VG amount and UI amount. So in the table, the extra left-hand column with UI symbols and the extra top row with the VG symbols represent values that must be computed for all cells with allocations using the formula of UI plus VG equal to CIG. So there are 8 cells with allocations and need to solve the equation using the formula mentioned just now to find the value of each of UI and VG. After calculating, the values of UI are as shown in the table, which are U1 equal to 0, U2 equal to -3, U3 equal to -3, and U4 equal to -2. As for VJ, the values are as shown in the table, which are VA equal to 13, VB equal to 9, VC equal to 15, VD equal to 15, and also VE equal to 12. After that, we will calculate the values for the empty cell to find whether we can minimize the transportation cost by using the stepping stone method. So the results of the calculations for the empty cells shows that there are negative values, and so the stepping stone method is needed to find the minimum cost. There are three negative values after calculating the empty cells, which are -5 in cell U1 and VD, -1 in cell U3 and VC, as well as -1 in cell U4 and VD. So the value chosen is -5 because it shows the maximum reduction of the transportation cost. For the stepping stone method, the allocation to an empty cell will be conducted as shown in the table, following the arrow that has been drawn. So for each of the cells in the flow, will be written the symbol of positive or negative. Following the symbol of negative and positive, the values in the cells of the flow will be added or subtracted with the value in the second cell in the flow. So the result after added and subtracted can be seen in the second table, which is 3 in first cell of the flow, empty cell in the second cell of the flow, 10 in third cell, and 10 in the last cell. After the new value has been allocated in the cells, we will calculate the new total cost to find out whether the cost is reduced and can be minimized. So the new total cost calculated is $907. Therefore, the modified distribution method and stepping stone method is optimal solutions that have a minimum cost than the northwest corner method.
So, for the conclusion, by applying the transportation problem method, it can establish an initial feasible solution and minimize the transportation cost, reach the optimal transportation cost solution, and lastly achieve the most cost-effective and efficient distribution of goods.
Hi, Assalamualaikum. My name is Nurul Syafiqah binti Manaf. Now I will answer the question 2. All this information can be presented by network shown below. Find the critical path for each activity network. So today I will explain how to find the critical path for each activity network. To answer question number 2, we'll use the critical path method. The critical path method, or CPM, is a project management technique that defines tasks required for successful project completion. The critical path is the longest sequence of tasks that determine the project's duration. So, how to find the critical path? The first one is list all the project activities. Next is figure out the dependencies. Third, visualize your findings. Fourth, estimate task completion time, and the last one is calculate the critical path. Based on the question, we can see here the activity network. There are 6 activity networks, so I will list down each activity with its completion time taken to find the critical path. The first one is activity A, B, C, D, G, H, and M, which is when we add all the time they need to finish the activity, the time taken is 40 weeks. The next one is activity A, B, C, E, H, and M, which is the time taken is 31 weeks. The third one is A, B, C, E, F, J, K, and N, and the time taken is 43 weeks. The fourth one is A, B, C, E, F, J, L, and N, which is when we add all the time they need to finish the activity. The time taken is 44 weeks. Number 5 is activity A, B, C, I, J, K, and N, and the time taken to complete the activity is 41 weeks. And the last one is A, B, C, I, J, L, N. And the completion time taken is 42 weeks. So, we can see here that the activity network number 4, which is the activity A, B, C, E, F, J, L, N is the critical path since maximum duration is 44 weeks.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Akram. I will explain about the early start, early finish, latest start and latest finish. As you can see, each of the column at the left and the right top given in the question, so you need to write back. The first column from the early start must put 0. To get the early finish, we must add the number given with the early start. So, 2 plus 0 equal to 2. So, the early finish for column A will put in the early start in the column B. So, we will repeat the same process as we do in the column A. For the column C, E and F also repeat the same method. Before we go further, we look back into the column C. The column have two junctions, I and D. So we focus on the column I first. So column I will do the same method as we did before the past column. Before we go through column J, we must look where the source of the column J by looking the arrow. So the source are from I and F, and then we need to choose the biggest early finish number. So in the case we choose 25 because the biggest numbers. After that, we do same method like we do before. From the column J have two junction, L and K column. So for the early start, column L and K will take from the early finish in the column J. Before we go through column N, we must look where the source of the column N by looking the arrow. So the source are from L and K, and then we need to choose the biggest early finish number. So in the case we choose 38 because the biggest number. After that, sum operation to get the early finish for the column N. Now we look back at the column C again. We do the same operation until D and G columns. Before we go through column H, we must look where the source of column H by looking the arrow. So the source are from E and G, and then we need to choose the biggest early finish number. So in the case we choose 29 because the biggest number. After that, we must do some operation to get the early finish for column H, and then we do the same operation for column M. So that is the solution for early start and early finish. Okay, next, to find the latest start and latest finish, we must put the column N and M latest finish 44 because the critical path is 44. So both column we do the minus operation they already given number as shown in the equation diagram. The next step we do the same operation for one arrow source only, but if the source come from two arrow, we will choose the but if the source come from two arrow, we will choose the smallest number. For the example, column E come from the two source which F and H, so we choose the smallest number which is 20. So continue the operation until column A, but the column split into the two source, we put the same number for the latest finish. So that's all for the solution for to find the latest finish and latest start. So for the conclusion, project management is very important for organization to control, and by applying CPM method can firstly optimizing project duration by minimizing the total project time and cost by identifying critical activities and prioritizing them, and lastly managing large scale project, scheduling and staffing individual activity across the organization in a step-by-step priority-based manner. That's all from me. Thank you.
My name is Muhammad Adik bin Ghazali and I will explain the question 3 in project 4. Okay, question 3 is under linear programming, LP. So mathematical programming is used to find the best or optional solution to a problem that required a decision or set of decision about how best to use a set of limited resource of achieve a state goal of objective. There have 3 steps involved in mathematical programming. Okay, the first one is conversion of state problem into a mathematical model that abstract all the essential element of the problem. Second is exploration of different solution of the problem, and the last one is finding out the most suitable or optimal solution. So the question 3 is under product mix problem, which is have 2 steps. The first step is develop LP model, and second step is graphical solution, which is graph. Okay, the formula for this topic is Z equal to A1 x 1 plus A2 x 2. So the solution for this question is the company has decided that it want to maximize its manufacture in a day to get maximum profit. And the second is therefore the decision variable x1 and x2 can be the number of unit of machine 1, 2 and 3 respectively produced per day. So that's all intro about LP, and I will pass to the next presenter. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and my name is Muhammad Amir Afiq bin Rahim, and I'm going to explain for the answer for question 3, which is linear programming. So the table reads as follow: machine 1 take 12 minutes for type A and 6 minutes for type B, and machine 2 take 18 minutes for type A and 9 minutes for type B, and machine 3 take 6 minutes of type A and 6 minutes for type B. So each machine is available for 6 hours per day, which is 360 minutes equal to 6 hours, 60 minutes per hour. The profit for each type A toy is RM7.50, and the profit for each type for B toy is RM5. Let X and Y toy of type A and type B respectively be manufactured in a day. The given problem can be formulated as follow. Next, I'm going to explain for question 3, which is through the formulated equation, which is the answer. At A, we have Z equal to 7.5 and 20 plus 5 times 0 equal to 150. At B, we have Z equal to 7.5 times 0 plus 5 times 0 equal to 0. At C, we have Z equal to 7.5 times 20 plus 5 times 20 equal to 250. And at D, we have Z equal to 7.5 times 15 plus 5 times 30 equal to 262.5. And at F, we have Z equal to 7.5 times 0 plus 5 times 40 equal to 200. From all this equation, we can see that at D, we have the maximum profit, which is 262.5. Hence, the profit is maximum at X equal to 15 and Y equal to 30. Besides the equation, we can see the graph, which is show the equation that we can get from there, and we apply it to graph. In conclusion, linear programming is valuable and widely used mathematical technique with application in various fields. Its importance lies in its ability to help organization and decision. By linear programming method, we can optimize of resource. We also have cost reduction, production planning, and financial planning. At last, linear programming plays a crucial role in optimizing decision-making process, improving efficiency, and enhancing overall performance across a wide range of industry sectors. Its versatility and applicability makes it an important tool in operational research. That's all from me. Thank you.